Hello friends, welcome to another episode of DevOps series. So in this session, we are going to cover a very critical component of the DevOps, okay, which is the container. Okay, so if you have some idea about the containers, okay, or maybe if you have heard about the containers, then I'm sure you must heard about the term Docker, right? So Docker is one of the containerized solution. That means it provide you the capability to create the containers. Okay, but Docker is not only the containerized solution. There are multiple containerized solution. Okay, so before giving you the complete end-to-end details of the container, what exactly is the container? Okay, so I'm going to explain everything from the scratch. So if you have any kind of a doubt in terms of the container, then definitely you are going to get it clear by the end of this session. Okay, but before that, let me tell you, Docker is one of the containerized solution, and along with Docker, we have some more containerized solutions that are available in the market. Okay, and if I name some of them, okay, one is Container D. So basically, Docker is also based on this particular Container D. Okay, then we have CRIO. Okay, and then we have Podman, which is an open source from the Red Hat. Okay, and then we have an enterprise version of the Docker as well, which is called the Marantis Container Runtime. Marantis, and then Container Runtime. Okay, which is a form of Docker enterprise version. So now all these softwares or technologies, okay, are for the containerizations. That means to create the containers. Now the question is, what is container? That is fine. We have a Docker and few more softwares are there that we can utilize to create the containers. But what is container? What exactly is there inside the container? And what are the benefits of the container? Okay, so once we'll move with the subsequent sessions, okay, then definitely container is going to be one of the critical component in the DevOps, where we will install and configure the Docker as a containerized solution. On top of that, once we'll go for the Jenkins, then what we do, we directly do the deployment of the containers instead of the specific applications. Okay, so it is very important to understand what is container from the scratch. Okay, so that you can get a better understanding of the DevOps, right? So let me start with the Docker introduction, and let me give you the introduction to the containers. What exactly is the container? Okay. Now before that one, let me start with a real life example. Okay, I'm sure you heard about the containers in the shipping industry, right? We have a large containers. Specifically, I'm talking about the shipping industry. Okay, where a large number of goods and products shipped from basically from one country to the different country. Okay, it could be in the same country as well, but majority of the container that we utilize for shipping of the products or the goods from one country to another country, right? So what we have exactly inside the containers, the very first thing, the containers are of standard shape and size. Okay, you will have a standard size and shape of the containers irrespective of the product that is packed inside the container for the delivery. Correct? There could be multiple products inside the container that is going to be shipped from one country to another country, and the size of the product could vary. Right? There could be multiple items, and based on the items, the shape and size, or you can say the packing or packaging of the items inside the container different. Right? But as a whole, the container is specific shape and size, right? And what we do, we pack all the items inside the container, and to send these content or product from one location to different location, or you can say from one country to another country, we just transport these containers, right? So at the source end, the container will be loaded, and again at the destination end, it will be unloaded, right? And then the corresponding product will be extracted from the containers, right? So now the concept that we are learning here, irrespective of the type of the product or the size of the product or packaging of the product that we have inside the container size is fixed and standard, right? And we are shipping all the products with the help of this particular standardized containers. Now if we compare it with the containers in our IT industry, okay, so the concept is almost same. And before that, let me explain you with a few more example by taking the industry's example. Now suppose that we have to install certain kind of a software in our machine for some purpose, right? For example, this is our server. So what we do, we install the different softwares and applications on that one, right? For example, if I have developed some application in the Java, so what I need to install a Java based application server, correct, where I can deploy my Java based applications. Now I want a front end web server to work as a reverse proxy to send the request to our application server. So you need to install the web server as well, right? Your applications may need to contact the database for the data, right? So that means you need the database as well. It can be on the same machine, or basically it could be on the separate machine, specifically in the production environment, right? And then when we install the different softwares, okay, for example web servers, Java based application servers, or any other application servers, so there are a lot of dependencies, okay. Some library files are there, okay. So these library files could be OS specific, okay, and it could be your application specific, right? So this could be your jar file, or it could be some other library files which is specific to required at the OS level, right? So that means in a nutshell, we have a lot of different kind of a softwares, applications, our data, and then along with that lot of dependencies, dependent libraries and softwares as well, right? And then we make a system up to date and ready once we have the complete end-to-end installation of all these softwares and applications in the system, right? But now think about the complexities. Now this is one of the server. If I'm going to in a real-time environment and I have to build up the same environment for my production and pre-productions, so there could be multiple number of servers, right? Not a single server. There could be multiple virtual machines or physical servers are there, correct? So whatever the work that we have done here, this need to be repeated in each and every machine, correct? Now think about the complexity of this one. And this is a real world scenario. And the real world scenario in a location where the containerized solutions are still not in use. Okay, this is a complete manual process. You have to create the virtual machines or maybe physical servers, right? And then you have to completely install and deploy all the applications, software, codes, database from the scratch. This is a very huge time taking process, and there are multiple drawbacks as well. For example, if you go for the scalability, right, today you have only 10 servers, tomorrow your business is increasing, number of users increase, you want 4 more new servers, then again you have to buy 4 virtual machines, and then you have to again follow same set of exercises in all 4 servers, and then you can plug into the existing environment, right? So that means the complexity is very high, it is time taking, complexity is very high, there could be a chance of manual errors, right? Scalability is not easy. So these are the multiple drawbacks of these kind of a traditional way of managing your application, software, and deployment, right? So what is the alternate of that? If I would like to save all this time, whatever the work that I am doing here, okay, I should save the time, I should not do in each and every machine same thing again and again. So for that we have a solution which is called your containers. Okay, now what is container? And let me tell you. So instead of doing the same thing again and again, containerization or a container is a technology which is a package of your applications, code, dependencies, okay, in a single package. just like we zip the multiple files, right? And similarly in Linux we create a tar file, which is a package of multiple files, right? When we create the backup. Similarly, your containers, which I am referring as a package, it contains all of your application, all of your software, all of your code, all of the dependencies, whether it is a OS level dependencies or whether it is an application level dependencies. Okay, everything is contained inside the container, right? So now, in the sometime back, I have drawn a server, right, where I have mentioned the web server, your application server. Then here you deploy the code. Then you have dependencies, right? You have multiple dependencies, OS level dependencies, your application level dependencies. You may have a database. You have a multiple other softwares as well, right? So now what we do, instead of a complete virtual machine or server, we packed it inside a container. So that means it is a package which contain everything, my software, my application, my code, along with that the dependency files as well. And once it is packed in a container in the form of a package, right? So now if you want to build some new environment or some new servers, or maybe you want to build your some different environments like development, testing, pre-production, production, right, where you have a multiple number of servers, correct? For example, here 6 we have. So now once we have a package which contain all of the software application code and dependencies, I can just move this package to the different machines and just start it. Now it is going to take a couple of minutes only to build the new systems, okay, or you can say new parallel systems very quickly. Instead of doing the everything from scratch, you just need to take the container, which I am referring as a package, and just you need to deploy or pull it in on the other different machines, and after that you just need to start the container. And starting the container means whatever the services that you have inside the container, for example web services, your application servers, your database, or any other software, that can be started once you are starting a container. So now think that how efficient it is in terms of the provisioning of the new machines, provisioning of the new environments, and in terms of the scalability, reusability, right? So this is the container which contain everything. Now let me give you some small information about the dependencies, because a lot of time I've seen many engineers are confused on the what exactly are the dependencies, because this container contain your all the application software code and a lightweight OS image as well. This is a very important point. Lightweight OS image. Okay, and this lightweight OS image has all the OS level dependencies that is packed in your containers, right? Otherwise, what happen is that in the traditional way, many times we see that a code which has been developed and tested in the development environment, once it is moved to a testing environment, then lot of the features or the functionalities didn't work in the testing, however it worked perfectly in the development. And that is mostly happen that there are certain kind of environmental issues, or sometimes many times there are a lot of different kind of dependencies are missing in the testing environment which was there in the development environment, right? To avoid this kind of an issues, we have the containers, right? Because it contains the complete dependencies, and in the dependencies you can consider it has a lightweight OS image. Okay, so now let me explain you what exactly it is. When we say the lightweight OS image, okay, then what exactly it means. So let me quickly clear it, and then I will explain you. I would strongly recommend do not miss a second of this video, because I am going to explain everything from the scratch, okay, and definitely you are going to get a good knowledge of the containers from the base. Okay, now suppose that this is my container. Let me draw it. This is my one of the container. Okay, so what I said, this will contain your application, your code, and your software like your web server, your application server, some other softwares as well. It may be your database, right? And along with that, it has a light weight OS image. Okay, basically it is a Unix based operating system image. Okay, this lightweight. Now, why we call it a lightweight? Because if we compare it with the virtual machine, so what happens in the virtual machine? A virtual machine is a complete operating system, independent operating system. When we create the virtual machine, okay, so it contains the independent operating system, right? So virtual machine is very heavy because it is has a complete OS. But when we talk about the container in comparison with the virtual machine, okay, it doesn't have the complete OS image, but only it has a lightweight OS image, and this lightweight OS image will be in the MB. Okay, however, if you go for the complete OS, which is in the GB, right? And you can't just transfer this OS from one machine to another machine, just like we can move the container from one machine to another machine. Okay, so now what exactly in this lightweight OS image, there are multiple things that is specifically related with your operating system. For example, we have a shell. In a Unix based operating system like the Linux, we have a shell like bin sh, right? And then we have multiple utilities like ls utility, cp utility, then we have move, rm, mkdir. Along with that, we have a certain networking utilities like ping, and then apart from that, we have a multiple libraries. Those are built in C, C++, and many other languages, right? So these are the dependencies, or you can say the important other configuration files or the command or utilities, okay, that is bundled in this particular lightweight OS image. Okay, these are a few examples, okay, which will contain in a lightweight OS image. Okay, so specifically when we talk about the library files which is installed at the OS level, this is also packed in this particular lightweight OS image. And this is hardly of MB because this shell, all these command files, utilities, libraries are not going to take much space. It is hardly going to take certain kind of a MB, right? So now this container has all the application code, software, database, and every other software along with the lightweight OS image. And this is very important point to note in specifically in terms of the containers. Lightweight OS image, because once you go for learning the Docker or containers at the advanced level, okay, then this will come in the picture. OS image, lightweight OS image, because during the creation of the containers or during the creation of your customized containers, okay, there are a lot of places where will come which image you want to build, which image you want to create, what are the content that you want to create inside the image. Okay, so that's why it is very important to understand. So as of now we are just understanding the container, so this is sufficient for you to understand. Along with the application code, software dependencies, it contains the lightweight operating system. And what we have inside the lightweight operating system, these are the some contents that will be inside your containers, and you can say in the lightweight OS image of your container. So that means it is very lightweight. Why it is a lightweight? Because it is containing the lightweight operating system, which is specifically size of a MB. So it is lightweight, right? So if it is a lightweight, so it is very easy to move from one machine to other machine, right? So now let me give you a few more information, and let me first tell you about the small architecture of this containerized solution. Okay, and then I will tell you the benefit of that one. Now, what is the architecture is very simple. This is your hardware, or you can say physical server, right? On top of that, we install the operating system, correct? Once your operating system is there, you can install the one of the containerized solution, and I am talking about the Docker, which is one of the leading containerized solution. Correct? You have installed a Docker. So once Docker is installed, on top of that, you can create the multiple containers. Container 1, container 2, container 3, container 4, similarly 5, 6, and n number of containers, whatever you want. Correct? So we have a multiple containers here. Just like we create the virtual machines. The difference is that these are the lightweight because it contains the lightweight OS image. Correct. And now suppose that if you want to move your containers, this is your development machine, right? And now you have a testing machine as well. This is your physical server of the testing environment. On top of that, we have a operating system, and then you have installed the Docker. Right. Now, what you can do once your development environment is ready, you can take container and you can move it to the, or you can copy it to the testing environment and create the multiple replicas of same container. So within a couple of minutes, whatever the software data, whatever you have in the development, it will be in your testing environment within a couple of minutes. And similarly, this can be replicated in some other environments like your quality, pre-prod, testing, production, anywhere. And every environment can be up and ready within a couple of minutes. Right. So this is one of the beauty of your Docker, or you can say the containerized solution, which is going to save you a lot of time, which is going to increase the end-to-end efficiency, which is going to eliminate the many of the manual errors that we get in the traditional environments when we build the environments and configure the applications, right? So now one of the important question here could be, if you have multiple containers here, right, and how the resources are going to be utilized at the OS or the physical server level. For example, we have a 20 GB of RAM and 40 CPUs, right? Now if you have multiple containers, how they are going to utilize all these resources, because it is going to be shared between all, right, all the containers, and each containers are completely isolated from each other, right? So in when we create the containers, so we have a different ways to control the resources as well. For example, if you are creating this container and you want to assign only 1 GB to this container, and you want to assign only 2 CPU or 2 virtual CPU to the containers, then this can be assigned once we create the container. Okay, this is the part of your commands, and in command we can specify what is the resources a particular container can take. Otherwise, what will happen, if some container run into any issues or a heavily loaded, right, so it will take all the resources from the physical server level and other will not get the resources. So it is important to distribute the hardware properly between your different containers. Correct. So this is all about the containers. So what are the benefits that we are seeing here, specifically when you are using the containers, right? So the first benefit is, will not get a situation where code is working in the development and it is not working in the testing environment, or maybe in the quality environment or anywhere, because everything inside the container, we are just moving the container from one location to different location. So it is exactly same copy whatever we have in the different environment, right? So that means reusability increased. We can create one container and we can reutilize it anywhere wherever required, right? It is very lightweight and easy to move between the different environments. So that means it is lightweight and very fast, right? And then portability. Portability means whether container is in development environment, it is in testing environment, it is in pre-production environment, you can easily move from one location to different location. There could be some parameters, environmental variables, that may be different between the environments. So those parameters you can pass at the runtime. Okay, you have complete flexibility. For example, you say that in development my RAM, the JVM heap size is 1 GB, but when I go to testing it could be 2 GB, and when I go to production it can be 5 GB or 6 GB. So these kind of a runtime environment we can pass with the help of environmental variables. Okay, then next is scalability is very easy. If you want to spin up new virtual machines, if your load is getting increased, you can just copy the containers and you can spin up or start the containers, and within a minute you can start n number of containers in parallel, right? So this is scalability is very easy and very fast. Deployment and rollback is very fast, right? Whenever you have a new application going to be deployed, okay, for example you have a 1 2 3 4 5 6 containers are there, okay, so you can automatically schedule the deployment, Okay, so that the deployment will be done on the first container. Once it is success, then it will go to second container. Once it is success in second container, that it will go to third container, and similarly it will move. So that means you can do the deployment in the rolling fashion without downtime. It is a deployment in the rolling fashion within downtime. And similarly, if you are going for the rollback due to any reasons, so rollback can also be done in the one by one cyclic order, rolling fashion. So that means deployment and rollback will also be very easy, very fast and efficient. Okay. And for end-to-end management of the multiple containers, we have some solutions in the Docker itself as well. But main tool that we use for the management of the multiple containers, okay, which is called the Kubernetes. We are going to cover in the next sessions. Kubernetes, which is an orchestration tool, okay, which is just used for the end-to-end management of the multiple containers. You have multiple containers, you want to manage all multiple containers centrally. For that we have a Kubernetes, okay, that we are going to cover in the Kubernetes session. So this is all about the container, and I hope you have now got a good understanding of what exactly is container, what we have inside the containers, why it is very efficient tool, why, how it increase the efficiency of the users working in the environment, right, and overall the system as well.